So this is the pre-quiz, and let's do 1 through 4. Yeah? Okay. So number 1, this is what I think you're doing. Okay, so number 1, our index finger is that way. Hopefully nobody will walk through the door while we're doing this, right? Middle finger is that way, right? There we go, right? And the thumb is out of the page, and that little dot means out of the page, right? And then this one, our index finger is into the page, yeah? Middle finger is that way. Which way is my thumb pointing? Up the page, and that little thing means up the page, yeah? In physics land. Here my index finger is down. Middle finger is out of the page. Which way is my thumb? To the left, isn't it? So that little guy means to the left, okay? And then this one is out of the page. Middle finger down. My thumb is pointing to the right, and that little thing to the right is, there it is, right? Okay. So 2 is the other right-hand rule. I think it's right-hand rule number 1, okay, that we learned last time. This one you put your thumb in the direction of the current, and you wrap your finger around the wire, yeah? Okay. So it's going to be into the page on the bottom of the wire. Behind the wire, it's going to be up. On top of the wire, it's going to be out of the page. But since it asks for where it is, or what it is below the wire, it's definitely into the page below the wire, out of the page above the wire. Yeah? Okay. So in general, with that wire, it is... In general, with that wire, if you've got a current flowing to the right, it is into the page below the wire, out of the page above the wire. And it's stronger and stronger closer to the wire and weaker away from it. It's actually like a 1 over R thing. So how about this guy? Our thumb is up the page. Wrap your fingers around on the left side of the wire. Are your fingers going out of the page or into the page? I think out of the page, yeah? On the right side, into the page. But it's asking for the left side, so the dot is out of the page. Now here we've got the magnetic field. It's coming out of the page on top, and it's going into the page on the bottom. So which way does your thumb have to go to do that? To the right or the left? I think it's to the right, yeah? Into the page on the bottom, out of the page, yeah? And then here, we've got current going down. On the right side, it's into the page. On the left side, on the left side, it's into the page. On the right side, out of the page. So this is right-hand rule number 3 that we did yesterday. I think this is the second one that we learned, right? And then this one is for finding the North Pole, right? Okay. So to find the North Pole, you wrap your fingers the way the current goes, and your thumb is the North Pole. So which way is the North Pole? Out of the page, and that's what the dot is there. Dot is out of the page. Okay. How about now? Which way is the North Pole? North Pole is away from you, right? The South Pole is actually facing you, right? So into the page is where the North Pole is. Fingers like that. How about here, a coil like that? Current's going to the right on the front of the coil. Which way is the North Pole? It's the top, right? That's what that little up thing means, right? It means it's on the top, right? If this is the North Pole and that's the South Pole, which way does the current go on the front? Well, it's got to go up the front, down the back, yeah? Because this is the North Pole, yeah? We're going to do the skill set on this after break. Would you please study this before you take that skill set? Because break is going to be 2 weeks long, and you're going to eat fruit cake and stuff like that. And, you know. Okay. And then number 4, this is magnetic field and current. Okay. So remember that current is the first thing in the vector cross product. Magnetic field is the second thing, and your thumb is the force, yes? Okay. So for this one, class. So for this one, for the first one, index finger that way, middle finger into the page, that's what the X's are, right? So that's the magnetic field. Which way is my thumb pointing? Up the page, and that's what this little up the page is, right? Now we've got current up the page, magnetic field to the right. Thumb is into the page, right? Now it's like, oh my gosh, we got to find B. So let's see, I is this way, force is this way, right? This is my force. This is my current. Which way is the magnetic field? Into the page. It would be a bunch of X's all over this thing, right? Okay. Now we've got thumb this way. Magnetic field's got to be out of the page. So my force is this way. Magnetic field's out of the page. The current has to be up. Yeah.
So we always describe it in relation to the paper itself.
Yeah. Yeah. Always do that, right? Otherwise, we're going to go mad. And then for these guys, I'll show you this. The only trick is we're going to do positive charge moving is just like a current. Okay, so we predict for a positive charge moving through this, that means the current is actually going that way. Yeah, isn't a moving positive charge like a current? A very small current, but yes, a current. Okay, so for this one, we can do this one. Index finger down the page, right? That's the current. Middle finger out of the page, right? And our thumb points, the force is that way. So what's this thing going to do? It's going to curve that way. And when it's going this way, which way is the force? Straight up. Yeah. And then it's going to curve some more so that it's going up the page. Right? And now the force is going to be which way? Isn't the force always going to be at right angles to this velocity? Foreshadowing. What's it going to do? It's going to circle around and around. There we have it. Yeah. Okay. These guys are tricky with negative particles. It goes opposite the way that we predict, right? Because it's negative, and negative particles are like that, right? Okay, so it's going this way, magnetic field's out of the page, the force is up, but it's negative up. So it's down, yeah. That's crazy, right? Okay, which way must a proton move to experience a vertically downward force in a northerly magnetic field? Okay, the magnetic field is north. Let's see, it's got a downward force, so my thumb happens to actually be in the right direction, right? Vertically downward is into the page for map problems like that, right? And so a proton's got to move which way? West, and is west is the right answer. This is good, right? Okay, so again, let's do that again. It's a proton, so it's a positive charge, so we don't have to reverse our answer. So it's got a vertically downward force, thumb is down, right? Northerly magnetic field, so north, we put that up the page. Right? And so it has to move. Now it's the motion of the particle is our index finger. Okay? And then this is going to be an electron. So electrons are what charge? Negative. So we have to reverse our answer ultimately, right? Okay, so it's moving east. So let's get our finger pointed east. Okay? And it experiences a force to the north. Yeah? So my thumb is to the north. Motion is toward the east, or the current is toward the east, right? Okay, and so the magnetic field is into the page, only it's negative into the page, so it's out of the page, right? So there's so many chances to make a mistake, right? Okay, we could get one of the directions wrong. We could use our left hand instead of our right hand. Okay, we could miss the fact that it's an electron. So in all of these cases, you just end up reversing the answer. So just remember, always make an even number of mistakes. So if you use your left hand, also forget that it's an electron, and then you're correct. Isn't that neat? I'm just joking. It's like a joke. Is it a funny joke? Oh, no, it's not.